Alright, so this video will be part one of the segment addition postulate, which says that it allows you to use known segment lengths to find unknown segment lengths. So what it says is that points A, B, and C are on the same line, which means that they are collinear. And point B is between point A and C. We know the distance AC is the sum of the distances of AB and BC. So we can say that AC is the sum of both AB and BC. So the way we're going to write that is we're going to say AB plus segment BC equals segment AC. So we have small piece equals whole piece. Small equals whole. So example 1, we're given that EL equals 7, LF equals 3, but they want to know what EF is. So let's label our picture here. EL is 7, LF is 3, and they want to know what EF is. So we can say that our two small pieces are EL and LF, and that should equal the whole thing EF. So again, small piece plus small piece equals whole piece. I'm given what EL is, that's 7. LF is 3, and that equals EF. So 7 plus 3 is 10. In the next example, we're given EF is 29 and LF is 13. We want to know what EL is. So again, EF, that's the whole piece. They're telling us that's 29. They're telling us LF is 13. And they want to know what EL is. That's one of our small pieces. So again, we have small piece, EL, plus other small piece, LF, equals our whole piece, which is EF. Let's substitute in our what we know. EL, we don't know. LF is 13. And the entire EF segment is 29. So, in order to undo addition, I subtract 29 minus 13. The answer, EL, equals 16. Example 3, LF equals 82. That's one of our small pieces. It says EF equals 105. And we're looking for EL, which is one of the small pieces again. So again, my small pieces, EL plus LF, equal my large piece, which is EF. It's always handy to write those out. EL plus LF, which is 82, equals EF, which is 105. To undo addition, I subtract 82. And EL equals 23. Alright, now let's talk about the distance on a number line. Finding the distance on a number line. The distance between 2 points on a number line is the absolute value of the difference of the two numbers. So difference means we subtract. Alright. On a number line, the coordinates A, B, C, and D are -6, -2, 3, and 7 respectively. So the first thing we should do is draw out a number line. And I have A, B, C, and D. So telling us A is negative 6, B is negative 2, C is 3, and D is 7. Alright, so again, to find the distance between the 2 points, we find the absolute value of the difference, which means we subtract. So to find the distance between A and B, we're going to take A minus B. So A is negative 6 minus my B, which is negative 2. If I plug that in a calculator, negative 6 minus negative 2, that is actually negative 4. But we can't have a negative distance. My distance is actually 4. The distance from B to C, I take the absolute value of B minus C. So B is negative 2 minus C, which is 3. If I type in negative 2 minus 3 in the calculator, I get negative 5, but I need the absolute value, which is 5. The distance between C and D, as is C minus D, and I take the absolute value. C is at 0.3, D is at 0.7, I subtract those. That turns out to be negative 4. The absolute value of negative 4 is 4. Again, the absolute value is always positive. So BD, I'm going to take B minus D, and I'll take the absolute value. So B is at negative 2, minus my D, which is at 7, and I'll take the absolute value. Negative 2 minus 7 is negative 9, but again, absolute value is always positive. The distance is 9. And finally, AC. I'm going to take A minus C and take the absolute value. A is negative 6 minus C, which is 3, and negative 6 minus 3 is negative 9. The absolute value is 9. Now if they were asking which segments are congruent means they're the same length, you could say that AB is congruent to CD, because they're both 4. And you could also say that BD is congruent to AC. Those are both 9 units long. Again, if you're looking for congruent, you're looking for segments that are the same length.